Hey student, how are you? Welcome to our session on special right triangles and trig ratios. Let's start with the 30, 60, 90 special right triangle. The opposite side of 30 is 1. The opposite side of 60 is the square root of 3. And the hypotenuse is 2. 45, 45, 90 special right triangle. It's an isosceles triangle, so the opposite side of 45 degrees is 1. The hypotenuse is the square root of 2. Let's take a look at finding sine, cosine, and tangent of 30 degrees. And we'll use our special right triangle. We have the opposite side of 30 degrees, and this is the adjacent side of 30 degrees, and the hypotenuse is the side opposite the right angle. Sine of 30 degrees. Sine of 30 degrees is the opposite side of 30 degrees, 1, over the hypotenuse, 2. Sine of 30 degrees is 1/2. Cosine of 30 degrees. Adjacent side of 30 degrees is the square root of 3, over the hypotenuse. Cosine of 30 degrees is square root 3 over 2. Tangent of 30. Tangent of 30 is the opposite side over the adjacent side, 1 over square root 3. You could rationalize by multiplying by square root 3 over square root 3, multiply straight across, and we get square root 3 over square root 3 times square root 3 is 3. So there's our rationalized tangent of 30. Let's take a look at sine, cosine, and tangent of 60 degrees. And we have the opposite side of 60 degrees. This is the adjacent side of 60 degrees, and the opposite side of the right angle is always the hypotenuse. Sine of 60 degrees. The opposite side, square root 3, over the hypotenuse, 2. Sine of 60 degrees is square root 3 over 2. Cosine of 60. Adjacent side over the hypotenuse. Cosine of 60 is 1/2. Tangent of 60, opposite over adjacent, and we can reduce to just square root of 3. Tangent of 60 is the square root of 3. And let's take a look at our other triangle, 45, 45, 90 special right triangle. The hypotenuse is always the side opposite the right angle. And then the other two sides don't really matter. They could be the opposite or the adjacent. They're kind of interchangeable since they're both 1. Sine of 45 degrees. Opposite side, 1, over the hypotenuse, the square root of 2. And then let's rationalize. We'll multiply by the square root of 2 over the square root of 2. And we get the square root of 2 over square root of 2 times the square root of 2 is 2. We get the square root of 2 over 2. Cosine of 45 degrees is the same as sine of 45 degrees. If we rationalize, we get the square root of 2 over 2. Square root of 2 over 2. Tangent of 45 degrees. Opposite side over the adjacent side. And we can reduce and we get tangent of 45 degrees is 1. Now these values are always the same. Sine of 45, sine of 30, sine of 60 are always the same value. So let's take a look at a 30, 60, 90 special right triangle that has been scaled up by 5. Every side has been multiplied by 5. Let's start with sine, cosine, and tangent of 30 degrees. Opposite side of 30 degrees is 5. Adjacent side of 30 degrees is 5 square root 3, and the hypotenuse is 10. Sine of 30 degrees, opposite, over hypotenuse, and this reduces to 1/2. Sine of 30 degrees is always 1/2. Cosine. adjacent over hypotenuse. 5 square root 3 over 10. And we can reduce this. 5 over 10 is 1 over 2. We get square root 3 over 2. Cosine of 30 is always square root 3 over 2. And tangent of 30, opposite over adjacent, we get 5 over 5 square root 3. 5's cancel out, and we're left with 1 over square root 3. 1 over square root 3, which we can rationalize, and that will equal square root 3 over 3. Tangent of 30 degrees is always square root 3 over 3. And then let's rename our triangle, and we'll work with 60 degrees. Opposite side of 60 and the adjacent side of 60. Hypotenuse is always the opposite side of the right angle. Sine of 60, opposite over hypotenuse. Whoop. Square root 3 over 10. And we can reduce, and we get square root 3 over 2. Sine of 60 is always square root 3 over 2. Cosine of 60, adjacent over hypotenuse, and this reduces to 1/2. Cosine of 60 is always 1/2. And tangent of 60, opposite over adjacent. The 5's cancel out, and we are left with the square root of 3. Tangent of 60 is always square root of 3. Now let's do one more. We'll do a similar 45, 45, 90 special right triangle. This one has been multiplied every side by 4. And this is our hypotenuse. And then this could be opposite or adjacent. They are interchangeable since they're both 4. Sine of 45 degrees, opposite over hypotenuse. 4 over 4 square root 2. The 4's cancel out, and we're left with 1 over square root 2, which we know rationalizes to square root 2 over 2. Sine of 45 degrees is always square root 2 over 2. Cosine of 45 degrees is the same. 4 over 4 square root 2 reduces and rationalizes to square root 2 over 2. Cosine of 45 degrees is always square root 2 over 2. And finally, tangent of 45, opposite over adjacent, reduces to 1. Tangent of 45 degrees is always 1. And that concludes special right triangles and trig ratios. Thanks so much for joining our session, and I'll see you next time.